Hi everyone, in this video I'm going to show that many common household items can run on DC wall power. So let me show you the setup I have. It involves a rectifier, and I'm going to move the camera closer so I can show you. So here's my setup. I'm going to be using this rectifier to turn the AC wall power into DC power, and it's going to be pulsing DC. So I've got this 560 UF capacitor that's rated for 200 volts. And I'm going to use that to smooth the power. And the DC voltage is going to be a little higher than the AC voltage because it's actually converting the peak voltage, not the RMS voltage, the root mean square, which is 120 or 125 or around that. So I've got these alligator clips connected to a phone charger, and they're connected to the AC input on the rectifier, and then I've got red and black so that I can keep track of positive and negative, and I've set it up so that the larger slot on the left is going to be positive and the narrow one on the right will be negative. So I'm going to plug this in. That spark was current rushing to fill this capacitor, and now we're going to measure the voltage. First we're going to measure the voltage on the outlet, so we're going to set this to 200 volts AC, and I'm going to try to measure the outlet voltage with one hand. Alright, so around 120. Now we're going to set this to 200 volts DC and see what that is. So about 167 volts DC. So now we can begin trying things out on DC power. I'm just going to turn the voltmeter off and put it down, and the first thing we're going to try is this Nightlight. I've augmented it with a neon bulb, and so we're going to see if it works. So as you can see, the Nightlight isn't working, but the neon light is. And I don't know if the camera is showing it, but only one side is lighting up. When you run a neon light on DC power, only the negative side lights up. Now I suspect that the reason this doesn't work on smooth DC power is because it has a series capacitor. So a series capacitor appears as an open circuit to DC, to smooth DC, but if I unhook one side of this capacitor, then it starts to light up a little, but it's still pretty dim. It's not as bright as it would be on AC power. So I think it has a series capacitor. Alright, so I'm going to unplug the neon light now. And the next thing we're going to try is the Baofeng Walkietalkie charger. So as you can see, it works. And it looks like most current power supplies can run on DC power because they're switching power supplies. Old power supplies that are really big and heavy wouldn't work because they use a transformer, and a transformer appears as a dead short on DC. Alright, now let's try the TV. So it works. Now, while we've got the TV on, let's try the Raspberry Pi. Let me get an HDMI cable. I've got a 2 amp Raspberry Pi USB power supply. So here it is. It's not official Raspberry Pi, as you can see, but that's what it's basically for. So I'm just going to plug this in, and the Raspberry Pi lights up, and as you can see it works. So you can run a Raspberry Pi on DC power from its power supply and a TV. Alright, now I'd like to demonstrate a USB charger. This is an Amazon USB charger, and I'm just going to plug it in and demonstrate charging a couple of things. So first I'm going to charge this phone. And yeah, that screen protector is a bit ugly, so I peeled it off. But yeah, as you can see, it charges the phone. Now I'm going to demonstrate charging the MP3 player. And that works too. You can also charge that Canon camcorder, so I'm going to get its power supply and show that. So here's the charger. I don't know how well you'll be able to see it, but it's an 8.4 volt charger. So I'm just going to plug this in and charge the camera a little. And it works. Normally you wouldn't expect a motorized device to work on DC power, but this does. So I'm going to show you. I want to make sure it's off, then plug it in. It's a little bit faster on DC than on AC. I think that's because the voltage is higher. Now I'm going to demonstrate a Philips scene switch light. These lights are interesting because they can do 3 different settings. The soft white incandescent color, the white daylight color, and a really dim incandescent color. So I'm going to plug in that lamp and then put in a scene switch bulb. And let me make sure that it's in view. And it works. If you've ever taken apart an LED bulb, then you'll know that it's all powered by DC internally. So the first stage is a rectifier, and then everything after that just receives DC power. So that's why these are able to run on DC, because they already do anyway. Alright, the next thing I'd like to demonstrate is this floodlight. It's 20 watts. It's supposed to be the equivalent of a 100 watt incandescent bulb. And it runs on a wide range of voltages from 85 to 265 volts. So it's got some kind of power supply that's able to accommodate a lot of different voltages. So I'm going to use the red and the blue terminals. The third one is ground. And I've disconnected the capacitor so that I can have some spare alligator clips. And just to match the colors, I'm going to put the red on the red and the black on the blue. So I'm going to return this to its box and put it down. Now, the last thing I'd like to demonstrate is something you really wouldn't expect to work on DC power. Let me reconnect this capacitor. I'm being careful not to touch the terminals because it probably still has voltage in it. So, there, that's reconnected. And this reciprocating saw works on DC. Now it has some lights right there. Let me turn it so you can see. So right there it has some lights, and when it's plugged into AC power they turn on, but just like with the Nightlight they don't do anything on DC. So I assume this also uses a series capacitor. Like with the mixer, this is going a bit faster than it would on AC power, so that's that. Okay, so now that I've demonstrated all these things, I want to explain why this is significant. Because if you've already got AC power, why would you need to run these things on DC? Well, if you've got a battery backup system, like from solar power, then you would normally have to use an inverter, and that has an efficiency loss. And so if you can run things directly on high voltage DC, then you have higher efficiency.